Hi guys, my name is Akash Pawar, and this video is dedicated to explore how we can instrument metrics and send it to Signoz cloud backend. So, and what is Signoz and how we can implement it, the entire flow. Before proceeding with the actual implementation, we're gonna see some basics and, for example, basics of observability and OpenTelemetry architecture. Then we'll proceed with what are the pain points with the current thing and how Signo is solving that problem. So let's start with that. Let me share my screen. Yeah. So one second, please. Okay. So we already know for this video we should have some understanding about microservices and how Kubernetes works. If it's okay if we don't have any uh, previous knowledge about the observability, let's see with that. We'll go with the basics thing, then we'll proceed how is the evolution and how the next generation tools solve this problem. So observability divided into three pillars. It has logs, metrics, and traces. Logs is something which is generated by applications. For example, application have let's say we have some WhatsApp. So whenever user logged in, when user sends something to somewhere, then it logs things, and that calls as logs, and we need it to know how the application behaving at scale. Matrix is something which is a numerical thing. It is more likely an infrastructure part, but it's not limited to the infrastructure. For example, we can have some sort of infrastructure visibility with the matrix, like the CPU utilization, memory utilization, etc. And what are the applications running? Is there any application which is stuck pending, or is there any error with any kind of applications? Is there any HTTP errors? All that thing will be um, uh, sh- monitored by, I mean, collected as in the form of metrics. Traces is something used to know how the entire flow is working. Let's say we have 10 different microservice applications. For example, we have a notification microservice. We have, let's, if you understand, take an example of UPI. We might have a transaction microservice. We might have a login microservice. We can have a notification microservice. All that thing. So how the flow is going? So when user first time enter a number, it sends some money to someone else. So how the entire flow works during that entire transaction. So that is monitored by traces, and we can instrument traces with various way. And specifically, why there are multiple ways to instrument logs, metrics, and traces. OpenTelemetry has a plus point, and we will gonna see soon what it solves the real problem. So, so logs, there are more popular tools to monitor all these things. For logs, we have something called Prometheus, which is very sorry, my bad. For logs, we have if we take an AWS specific tool, then we have for logs we have a CloudWatch. This is well known thing if someone has some understanding about the AWS cloud. So we have AWS CloudWatch, which collect logs. Another open source. This is specific to AWS. This is well known, so I took this as an example in my this demo. We have a metric. Metrics can be instrumented using Prometheus, and it can be stored in Prometheus itself. Uh, let's see. Okay, why? Let's say metrics have a Prometheus, and let's say traces. For traces, if we take a very well-known popular example, then we have a Jaeger, which is open source. And in AWS specific thing, we might heard something called X-ray. X-rays AWS way to record and visualize the traces. So, what is the basic problem with that before we go proceed with the open telemetry? So, we monitoring the same system, but at the same time, we have multiple tools to monitor everything. For logs, we might have some CloudWatch or Log CIO. For metrics, we have a Prometheus, and this later can be connected to Grafana dashboard, which is very rich in dashboard and visualization thing. And it can be visualized in Grafana. Then for traces, we have a Jaeger and X-ray and any other cloud specific tools to monitor it. So the first problem with this setup is that if we take this example, the to instrument CloudWatch logs, we need to use the cloud AWS SDK. And later, let's say in some point we want to migrate from AWS to some other cloud, then we are very dependent on AWS that AWS SDK cannot work with other cloud or any other than the CloudWatch. Then in that case, we stick to the AWS or if you want to move out of the AWS, then we need to do everything, the instrumentation part again. Then this is very recursive process, and in popular term, we call it as a vendor lock system. So that is one issue. Other issue is that we have three different tools or multiple tools to visualize the metrics and logs and traces of the same system. So that is one more issue. So we need some sort of solution which is vendor neutral, which is also uh, flexible and can be uh, so I'll just list down the problem. Vendor lock-in problems. Vendor lock-in. There are many. I'll just listing what are the majors and which have the major concern with all the majority of the people. So one is vendor locking system. Second is multiple uh, tools for same system data. Okay, so let's go with these two problems. There are many, but let's go, and due to time constraint, we'll go with this only. And similarly for traces, we need to visualize Jaegers, and there are 10 different tools which can be integrated with it as well. So how OpenTelemetry play roles and what pain point? So one of the pain point we solved by OpenTelemetry here. A short introduction to the OpenTelemetry. It is open source project managed by CNCF. So what OpenTelemetry do is it has something called vendor neutral system, where we have okay, let's go with, I draw a diagram. I'll just explain it here only. So let's say how OpenTelemetry solve this pain point. Let's take first pain point, vendor neutral. So let's say this is our Kubernetes cluster, and let's say these are the pods, or let's say this is the namespace, and let's say we have a pod, a business application running app. Uh, we'll take a metric as an example, which is very aligned with the implementation we want to do as a part of hands-on learning in this video. We'll go with the metrics. Similarly, same flow will be implemented by for the logs and traces as well. Okay, so how things works in Prometheus, Grafana, and traces, and how it works with OpenTelemetry. Okay, so same in the, let's take an example, Prometheus. We have some sort of agent which is running here, which takes pods metrics agent, which takes the metrics from pod, which is be denoted if the pod is instrumented with the annotation which is needed to Prometheus agent to scrape the metrics. So this is scraped by this agent, and this sent to Prometheus database or the Prometheus server. And in terms of OpenTelemetry, we have something called uh, receivers. So let's say we have, uh, let's say this is the collector part, and this is the agent. So Prometheus has major component like agents, collectors, and inside the collectors there are three different things. Uh, those are receiver and secondary is processor, and third one is okay, and third one is exporter. So, and there can be multiple backends which can connect we which this exporter can be export their metrics. So there can be a CloudWatch, there can be uh, logc.io, there can be Azure Analytics, etc. Okay. So how it works is this agent collects the metrics from the app or the Cube API server. This sent to I'm just going with the very minimal architecture flow. This sent metrics to a receiver. So this receiver receives the metrics. We have a multiple receivers here. So we'll use one of that. For example, in terms of collecting the Kubernetes API metrics, we have a receiver called Kube cluster. So using this Kube cluster, we receive a matrix. Then this matrix can be processor in the sense we add some metadata in terms of metrics, like we attach the pod name, we attach some cluster name or namespace name, all those things in terms of metrics. In terms of logs, we'll see is there any API key which is accidentally or intentionally added in the logs, and any critical data is added in the logs. We can have some sort of functions which can process those data, and it removes from the logs. So all that thing which processor can handle. And after the processing of the logs or metrics of traces, this can be we have a exporter which export to a which can be export to a multiple backend, either it is cloud or logco or any other thing. So this solves first problem that this is not a vendor neutral. All the this same system logs, metrics, and traces. All these things are for the instrumentation of all three things. One SDK is being used, which is the OpenTelemetry SDK, and same logs or same system data can be exported to a multiple backend. Any point. Let's say now we using CloudWatch as our backend or the visualization tool. At some point, we decided some reason that we don't want to go with CloudWatch. We want to go with Logsio or Azure Analytics. So it's just that plug and push. So we'll just remove the plug from here and we'll attach Logsio. It's that simple. So we don't need to instrument all the metrics, all the instrumentation again. So it will be the same SDK, and it can be exported to any other backend. And so what is the so again, even though it's open telemetry solving one problem, that it is vendor neutral, it's solving first pain point, vendor locking. Then one more pain point solving is that all three things, I mean, logs, metrics, and traces can be instrumented with the same library. So this also pain point is solved by OpenTelemetry. There is one more thing. Even though we using same SDK for instrumentation of all those things, again it is exported to multiple backend. For example, logs is exported to CloudWatch. Metrics is exported to some Prometheus and then visualized in Grafana. Traces is exported to Jaeger. So even though we not solving the third problem, the multiple tools for the same system data. I mean the visualization, the end part. We have all the system data. Now we have to take some action on that data, but data is collected by three different things, and for we need to continuously switch between those. For if we want to check the logs, we have to look CloudWatch. If we have to check metrics, we have to look for Prometheus or Grafana, and same thing with the traces. So is there any tools which solve these problems? Why can't all three can go in the one place and it will be visual analyzed? So yes, there are things which is already built for that. We have something called Datadog, which collects all these things. Uh, Prometheus, I mean, logs, metrics, and traces can be collected at one place. Then okay, why not using Datadog? Then why should we go with the Signoz? So I'll go with that. Then we have one more. Okay, this is the one evaluation, and we solving few pain points. Then again, if we have one more tools, then we might have some different pain points. So this pain point is solved by OpenTelemetry, the first one, vendor locking. Multiple tools for the same system data. This pain point is solved by Datadog. Let me just delete this. Okay, this pain point is solved by Datadog. Okay, then why not be using Datadog? Okay, one oh few again pain point. The technical, I mean, the tools are evolved and we solved few pain points and new were generated. So pain point with this Datadog is will running out of time. We'll keep it very minimal. We have two major pain points in Datadog. It's very expensive, and the another pain point is uh, we cannot. It's not. It's not open source, so we need to do a lot of data compliant process. I mean, if some company have some data restriction, it should be stored on that. Then data compliance will be the issue with the Datadog or any other tool. So who can solve this issue, or is there any things like Datadog solve these pain points? Is there any tools which solving these two pain points? It is there, and I explored this in last week. So Signoz solving these two pain points. Okay, let's now come to Signoz and explore how it is solving these two pain points. And it's solving these two pain points. It's not means that it not solving the previous pain points. It's that it solved the previous pain points as well as it's solving the pain points in these evolutions. Okay, so Signos is open source. We can see a tool which is exactly Datadog competitor, which is capable of collecting logs, metrics, and traces. But it is also a open source tools. That means we can. It offers two services. Either we want to go with self deploy, or we want to go with managed. And for that, they give no name Signos Cloud. So if you want to go with self deploy, we can. Let me clear my screen. So one problem is solved by this. If you want to go with the self deploy, then data compliance issue will be solved by this. And if we go with the Signos Cloud, it will. And if we don't have this data compliance requirement, or it can be the same process we can follow for that, but it's very 1/10 of cheaper than the Datadog as per their report, Signoz report. So what we gonna see today is how we can let's take an example now. Let's go to the problem statement and understand the Signoz architecture in a little bit more. So to save some time, I already draw a Signoz architecture uh, to make it in very explain it in very less time. So let's understand. Let's understand. This is our Kubernetes cluster, and this is the cloud backend. These are the same thing as we saw in OpenTelemetry, like receivers, processors, and export. Before going with this, I want to show you something. There are, as I explained, Signos offer two way of using Signos: the self deploy one, and other is fully managed service. Let's go Signos charts. Signos offers two Helm charts. One is their Signos, which install components like, I'll show you. Is there anything they mentioned? If not, I'll go with that. Uh, I'll explain a little bit architecture. Um, so this is the Signos architecture. I took this diagram from their one of the official videos from YouTube. So this is our applications running in a Kubernetes cluster. There will be open telemetry collector, and it contains all that things: receivers, processors, and exporters. This export logs to a database, which would be a central database called ClickHouse. Then we have some extension like this is also one more pain point in Prometheus, that we there is a very glitchy process to have a cold storage system. So this one more problem is solving by the Signos. So they store all this data at a central database called ClickHouse, and then we can mention the condition that if after logs or metrics or traces data before 3 days can be go to the S3, which will be very cheaper again. And then in backend we have this query service, which will be executed by frontend. So when we go to their UI, it's like a Grafana UI where Grafana, Prometheus, and Jaeger collectively at once. The same thing, we all three things can be visualized at one place. So we have that UI. We'll go to the UI in some time. So when we add some query, it goes to the query service. Then query service further extract, I mean, try to search in ClickHouse, and based on that, it show the result to the front end, or it will get a response. So this is very simple architecture. And for scalability, they also have something called in case of ClickHouse, they have some Kafka service behind that, which will be very good to work at scale. So let's keep it simple for now. Uh, then okay, so let's try to segregate the components. If this will be our Kubernetes part. Okay, let's go to the our diagram. Where it is. Yeah. So let's understand this flow first. This is the flow for Signos Cloud. That means the backend is managed by Signos entirely. So we have our Kubernetes cluster. We have a few namespaces and a couple of applications running there. And our job is to get pod related metrics. For example, we want to get pod status. Either it is running, pending, or it has some issue and it is failing. So, and we should trigger an alert when any particular pod in the cluster is in pending state for last 5 minutes at any point. So that would be our problem statement. And for that, I implemented this thing, and we have to use all the Signos resources for that. So let's say we have this Kubernetes cluster, we have a couple of namespace and a couple of applications running. Then in the same namespace, we used Signoz Kubernetes, not this, Signoz Kubernetes infra Helm chart. Yeah. So as I said, they have two charts. This will be used ideally, as per my understanding, this will be used when we want to go with the Signos cloud. And the other one, this would be used when we want to go with the fully set up. That means the backend also are deployed at our end and the database has all the things. So for our example, let's go with this. This will deploy a collector and agent inside our Kubernetes cluster. And this thing, so collector and agent deploy as a daemon set. That means it will run at least one instance on every node, and collector will install, which will be a central thing. Then let's say then these agents get metrics. For example, in our case, we querying the Kubernetes API to get the status of the pod, and we not using any Prometheus related agent for that. We using native Signos OpenTelemetry agents. It will query Kubernetes API. It gets some metrics like pod phase, and it's sent through collector via service. Collector has a receivers. I mean, this Kubernetes cluster receiver, which I mentioned earlier in the video. This is responsible for querying a specific, I mean, getting the exact Kubernetes cluster metrics. So this receivers receives all the metrics. I will go through the values YAML file, which will be more descriptive and understandable to understand the flow. Um, then it will be received by the receivers. Then we processing it, like we are attaching some what we can say, some sort of tags and all. So that will be done. Then after that, everything happens. Then exporter export metrics to whatever the backends. In our case, we exporting it to the Signos cloud. Then inside the Signos cloud, we have all things. I mean, we can send logs, metrics, and traces. So we send metrics only here. So in the metrics explorer, we can query and we'll get a result. And if you want to set any alerts on certain condition of certain metrics, we can set via the alert options they have in the cloud. So this is the very simple flow. And now let's go with, for the implementation part, I have created all the things required. So go through this GitHub repo which I created, Signos solution. And here I mention all the architecture diagram. And okay, why? 1 second. Let me just read. Here I'm created all the steps required to demonstrate this demo. I mean this project. We want to ensure. Okay, let's go with actual things. Okay, there will be something authentication needed to send data to Signos cloud. Otherwise, anyone can send the data. So once we created our credentials, we can go in account setting. And once we go to the account setting, then we can go to the ingation, and here we can create the API key. API key is used in Helm chart, where we gonna give a secret, which will be used for the authentication while our collect exporters send data to the Signos backend. So I created one here, uh, Akash for this one, and I used in my values file or in a secret, and from that secret I'm referring the manifest from that secret for that value. And we also need this ingation URL. So our exporter is supposed to know where it should be sent, and it sort of needs some permission for that. So API is sort of password to open this door for sending the data. So this will be the ingation URL. It's like opening instagram.com and entering your password. So this will be a instagram.com, and this would be the password required to log into the account. Yeah. um, okay, so once we go there, so now let's go to the, I'll directly go to the values files, which will explore much more descriptive how the flow is. So yeah, so the flow will be agent is sending all the data to the collector. In the collector, receiver receiving the data, then processor processing the data, and then after that exporter exporting to the backend. So in our case, Signoz cloud. So it's like a chain like thing, agent to open telemetry collector, then it's sending to the Signoz cloud. So for that, we enter the open telemetry URL here. So what is the URL? Once we uh, you okay, I'll go with that first. So when we deploy this Helm chart, it creates some sort of thing called service. Get okay, wait, my bad. Get SPC. Okay, yeah. So this is the service which is created by. I mean, this is the entry. Just like the exporters have entry point with this domain. I mean, with this engagement URL. So role is playing by. I mean, same role is played here by this for the agent. Okay, so this will be the address to send the data for the agent. Okay, and for that, since it is on local network, we don't need any authentication for that. So we kept since we don't want to send agent directly to the Signos cloud, we keep it as empty. Then we have something called preset. Preset is nothing but what are there might be a multiple features which we can enable or disable, but we might need few. So what are the needed things we want to enable? We can mention it here. So for that, we enable the open telemetry exporter, Kubernetes attributes, cluster metrics, and kubelet metrics. Similarly, we this is the agent related configurations where we enable the agents and all the things are default. Then we have a open telemetry deployment. So this the collector in the sense, and inside this we have a multiple options that receivers, processors, and exporters. So this will be the environment variables which is needed to for the exporter which can export the data. So here we created one secret and we added this key, and its value is the API key which we created earlier in the video. So through secret, it refers the API key, and whenever it needed, you to use that. Yeah. So these are ports. So if you're aware of some sort of cloud things, if you are the good example for this that um, when we deploy some application in EC2, and if the security group don't allow a port, then even though application is running, we will not able to connect to that applications. So the reason behind is that the port on which the particular service running, it is blocked for all the users. So it's just that since even we have a service running, even the application is running, if this port is blocked, then the agent will not be able to contact collector to send the data. So for that, we just opening the ports here. And then we have a config for receivers and all. So we have two kinds of things, two kinds of endpoints. I think HTTP is used for logs, even though we don't require, we added here. gRPC endpoint is one where on which we sending metrics and traces. And this is the configuration for receivers. We have two receivers, OpenTelemetry and Kubernetes. We just needed this right now, but it's okay. And then we enabling few metrics inside this receivers. This is one we needed to demonstrate our demo Kubernetes pod page. So uh, this is something which I struggled to understand this. So what I want to show is that how you can explore things when a particular key or a particular metrics is you're not aware, and you want to know what is and what data it exports. So what I did is I went through the OpenTelemetry docs official GitHub repo. I looked for this, I mean the documentation, and looked for this metrics. So what they're doing is it has a Gonj metric type. Metric can be a different types, time series Gonj. So Gonj is like it export numerical data, and every numerical data has some meaning. So for that, if kubernetes.pod.face if it has a numerical value 1, then we can understand that a particular pod is in pending state. If it is 2, then it is running. If it is 3, it succeeded. If it is 4, failed, then and so on. So once I understand this, I yeah yeah this will be needed in further when we try to create alert and dashboards. So same thing, we just enabling what are the things required, and I enabled some additional thing just to explore more Signoz features. And then we have, let's say we have a processor where we try to add some metadata like namespace, deployment name, and everything. And let's come to the pipeline. Yeah. Okay. Services is like a bigger object. Inside that, it might have some extensions and some pipelines. Extension is some extended thing or the features required for debugging and all. So, for example, we enable health check, which will be helpful to get health check for these things. Uh, Gpages, I think it's for some troubleshooting thing. I'm not sure about that. Then we have our critical thing pipeline. So we mention all the receivers, processors, and exporters, and pipeline decide the flow of this. So let's say we have a receivers, we have two receivers, OpenTelemetry and Kubernetes cluster. This is, I think, used when application is instrumented for the metrics and we receiving or the logs. Then we can, I think it's used there, but in our demo, I don't think it's used. Then we have Kubernetes cluster, which get the Kubernetes metrics like pod status, deployment status, and everything. Then we have a processors. There are well-known processors. This I think add some tags. Pretty not sure about this. I referred the documentation. Then this resource detection, it just identify on which port the metrics coming, and it just adds some tags there. Batch is that it sends the data in batches, so it will eventually increase the performance. Then we have exporter. Then exporter export data, and we exporting in this form, open telemetry form. Then for this demo, I just enable the metrics. Similarly, we can have a traces and logs. It's not well, I mean, it's not predefined that we might use the same or all the receivers or processors works for all three things, traces and logs. There might be few receivers or processors is only built for us logs or traces or metrics. So this is things I think I should explain. Yeah. So now let's go to the Kubernetes dashboard and let's see our output. So let's go to the dashboard. I already built it. So I named this. Okay. So let me edit this just to mention what actually this data is. So if I just, okay, here I can edit. Yeah. So what we doing is we added this metrics, okay, here. Metric name, we need to add here metric name, where this here we can add some sort of conditions or filters. I mean, if this metrics can be, there are multiple pods or multiple data coming for this metrics. So we want to identify, okay, I just need data for this cluster. uh, I mean, for this cluster I just need metrics for this cluster. Then we have something called aggregations within the time series. I mean, um, what would be, I mean, what data you want to see, either the average of the day result of the data or the minimum maximum, all those things. So we want to go with the minimum. So we just want to ensure that 300 seconds, I mean every 300 seconds, that means that it's a time span. So the meaning of this is that in 5 minutes, how many pods are there, uh, which are in pending state, or how many minimum pods are there which are in pending state. So as we learn, so output of this can be either 1, 2, 3, or 4. I mean the numerical value. If we, and 1 means it is in pending state and that's what we want, then we added here one more having thing where we adding the minimum of this particular thing in this span. So that will show the data which will showcase what are the pods which are in pending state at any point. Okay, so now let's see the result. So we filtering gathering data by Kubernetes pod name and Kubernetes namespace, and we can see Kubernetes pod.name is equal to Akash play pending pod, and it is from Signoz namespace. And one more pod is in pending state, Akash play pending pod default, and it is from default namespace. Now let's verify this inside our cluster. So I'll just listing Kubernetes get pods -a, which will list all the pods from all the namespace. And we can see the pending status for, this is the namespace in which this pod is running. So we can see Akash play pending pod default, and this is from default namespace and it is in pending state. And the same thing showed here. Akash play pending pod and it is from pending pod and it is from default namespace. And let's verify one more pending pod. This is one. This is from Signoz namespace and Akash play pending pod. It's the name of the pod. So the first one, Akash play pending pod, and it is from the Signoz namespace. So I hope this help you to understand a little bit. If there are any sort of questions, please feel free to comment out. I'll happy to help you. Thank you so much, and please give me a feedback in the comment section so that I can improve myself in future. Thank you so much. Thank you.